Now, if we are happy with the code, next step, naturally, when you work on the editor, is you want to build your code. So building in Visual Studio Code is driven through the task system. So everything is in task. It could be build tasks, it could be other tasks. For here, if you click on tasks bar, you get run task or run build task. Now what we're going to do here is I'm going to show you the task already configured. It's super easy to config, but for the time, to save time here, I have this one pre-configured, really straightforward. All I have to do is fill in two things. One is give a name to my task. So I named it build. So this is going to be my build task. Second thing I did was to specify the command I want to run. So in here, it could be an external program. You could directly call your compiler, or you could call any other commands you want to run. So in here, in my example, I have a script here, file. Let me show you real quick. It's located here. Essentially, all it does is it tells VS Code, hey, this is the things I want you to drive. First, go into my build folder, Xcode. This project is set up to build with Xcode. And then next step is to call the Xcode command line tool and build my project. That's all it does. So now, if I close this file without saving, now I can start building my project right from here and say build. Now Visual Studio Code is going to know, hey, these are the commands I want to run. This is the project I'm going to build. So everything is going to happen within the editor. You don't ever have to leave the editor to do anything. So now you can see my build is succeeded. Everything is good here. So at this point, we already have our code written and built. Next thing we want to run. You can also run your project inside Visual Studio Code. You can even debug. We have a debugger support built in here. So let me show you that real quick. So to debug, you're going to switch over to a different tab in here. It's like a bug and debug. So that's why it looks like that. Again, I'm going to show you the file already configured. Again, very straightforward. For most part, you're going to get it in the, in the snippet. So you're going to say, add a configuration, and I want to do attach debugging or launch debugging. We do support different debuggers on different platforms. On Mac, we do have LLDB integration. On Linux and on Windows, we do support GDB debugger. On Windows, in addition, you can also use the Visual Studio Debugger integrated here. So what I'm going to do here is, on Mac machine, I'm going to use LLDB launch debugging. Pretty much everything is here already in the template. All I have to fill in is tell VS Code the program you want it to launch. In my case, it's going to be this testbed project that I just built. This is my program. And everything else is pretty much already filled in. The only other thing I did was my current working directory. This is needed by this project. So I filled that in, and that's it. Now I'm ready to debug. Let me go back to find my file, the file we were looking at. In this particular case, we're going to debug. Let's see. How about we set a breakpoint right here? So this function is called collide circles, which means when two circles collide with each other, this function is going to be called, and we're going to see the breakpoint hit here. So I have my breakpoint set. Now let's go back to the debug tab. At this point, all I have to do is to press F5, or this error button here. This is going to launch my app right here. So this is this comes with Box2D project. It has a bunch of shapes on the screen. You see I have two circles. Now if I move this circle right there, make it collide with the other circle, now we hit our breakpoint. Now we are back in the Visual Studio Code editor. As you would expect, as a debugger, now we can start looking at the variable values. You can hover over, or you can see all the local variables in here. You can also watch complex expressions. You can see the value right there. If I can move it over, you can actually see the value in here. And we also actually have built-in support for multi-threaded programs. If your programs use multi-threads, you can see in here, this one is hitting on thread 1, but I also got other threads in this app, so you can view that right here. And the best part, of course, now I'm in the program, I can start stepping over to next line. As I step over, or I can say, go to this line. So my cursor is right here, and I can say, run to cursor. So it's going to run right there. As you move in the program, you're going to see all these variables, value is going to change. So yeah, all the debugging features are in there for you to use right away. OK, so I showed you IntelliSense, co-browsing, building, and debugging, kind of the whole cycles. So if you're curious about how IntelliSense works, now I'm going to give you a little bit of explanation for how everything works, IntelliSense-wise, because you might be curious. Notice that I had never done any configurations for IntelliSense to work. I literally just opened that folder, and everything works out of the box. Of course, I did set up the build task and debug task, but nothing for IntelliSense, right? Nothing. Let me show you what we actually do behind the scenes to make everything work. Now let's go to the IntelliSense configuration file. So here's a file that we actually create behind the scenes. If the defaults are good, you never have to touch this file manually. That's our goal. But if you want to change something in here, this is where you're going to change all the settings for IntelliSense. OK, so here's the magic. First of all, in order for IntelliSense to work, for example, if it's able to find you all the system headers you can use in IntelliSense, right, in the autocomplete suggestion, we need to know where your system includes are, what your system defines are. So what we do is two things. If we scroll back here, we auto-detect the compiler you have installed in common locations on various different platforms. In this particular case, I have Clang installed as part of my Xcode installation on a Mac machine. And we know this is where the compiler is going to be. And we detect that, auto-detect that. And the next step is we use that, and we query that compiler and say, give me the system defines and includes. That's how we find your system headers. So that's number one magic. Number two magic is right here. Now we have system includes, but what about user headers, right? So as we see in this particular project, I have got CPP files, header files nested in subdirectories. How do we find all those files? Now this is a new syntax that we just introduced in the latest release, which is * at the end of any include path. So workspace folder is basically my root folder that I opened. So putting * at the end basically tells IntelliSense to say, search everything recursively in this folder and find every single header you can find and try to resolve it. So that's the number two thing we do. Number three thing we do. What if my app not only uses headers I define, but also use headers from external libraries, which is very common, right? Which leads us to the next thing we have included here. This is an additional include path we put here by default. It says VC package. That is the keyword there, which leads us to the next demo. So let me show you what this is and how this is being integrated into Visual Studio Code. So VC package is an open source C++ package manager that runs on Windows, Mac, and Linux. It's available. Oh, I'm not connected. And it itself is completely open sourced, and then you can use it to easily acquire over 350 open source libraries today. It's already available across all platforms. So it's all here. And now, let me open a different demo app. Let me close this guy. And a different app. This app is super, super simple. All it has is one single CPP file right here called main.cpp. What it tries to do is to render a triangle on the screen. But for that, it uses an external web library called SDL2, right, which is right here. And of course, this demo itself is so simple, the structure is so simple that it doesn't have the source code of that library included. So a recursive search of the workspace root is not going to help us here. We need something external. So that's where VC package can really help, to help you grab the latest version of this open source library online. So let me show you something real quick, which is, this is like literally 2 weeks ago when we announced VC package being available on Mac and Linux, because it started on Windows, but now the support extended onto non-Windows platforms. So these are things I did before when I was preparing the demo. Was, hey, it is open source on GitHub, so you clone that. This is where you need to build VC package itself. Once that's done, literally that's all I did was to say VC package install SDL2. That's a library I want, right? It's going to put into the right place. Actually is here. This is the folder. So let me go back here. It's on VC package folder, installed. I'm going to find OS X version, includes SDL2. And it also gives me the libs file as well, which means I can use that to build my app as well. But now at this point, I have already got SDL2. And of course, right now I don't have that config. So that's why IntelliSense is showing me green squiggles. So everyone who have used this extension before probably are familiar with the green squiggles, right? Right? Yes. We green squiggle the lines whenever we cannot locate your headers. This is to tell you, hey, we cannot find SDL2, SDL.h file. Now, at this point, we still do provide an IntelliSense experience out of the box. Even if we cannot find the headers, we use a tag parser. Basically, it's a token-based approach, but doesn't have the semantic knowledge of your C++ code. Like, it doesn't follow through your pound includes. It doesn't deal with macros, stuff like that. So it doesn't have the most accurate information about your source code. This is what we're going to use when we can't locate all of the headers. For example, if you go to type, you see, hey, we have lots of possibilities for where the type could come from, right? This is the default experience if you don't have everything configured. Now, of course, we want a better IntelliSense, more accurate IntelliSense. I want to know what exactly the type is instead of a list of all the possibilities, right? So that's why we wanted to try to resolve this green squiggle here. As I said, I already have SDL2 installed, but I tricked the system by saying, here, by renamed the folder. Why? That's why it couldn't find it. But if I remove those, now let me go back and just reopen the folder just to make sure IntelliSense is kicked off and reparse everything. Now we can get rid of that message box. Everything is done, no more green squiggles, and I can prove to you that full IntelliSense is actually working by going to the type. Now we know exactly what your type is. This is the equation we just did with any libraries installed by VC package, because we know where VC package is installed, where your headers are, and we can use those headers to resolve IntelliSense errors in VS Code. Even better with VC package is not only you can use the headers to resolve your IntelliSense errors, but also you can use those lib files to build your project right here. So I have this one set up to use CMake. If you want to use CMake here, the only thing you really need to do is to turn on this flag to make VC package visible. that's all I did. And now, at this point, I can simply go into my build folder and do CMake. And this build my code. And now I can just run it right here. And we got a triangle using SDL2 library. All right, so that's everything I want to show you on Mac. Let's go back to Windows machine real quick. As I mentioned earlier, we do auto detection of the compiler and the queries for system defines and includes one platform I just showed you is Mac, but we do support other platforms like Linux. On Windows, we actually support a wide variety of subsystems as well. So we not only support MSVC, the Microsoft compiler, but also support like WSL, which is a Windows system for Linux, and MinGW, if that's what you're targeting, or Cygwin as another option. So let me show you that support real quick. Okay, it's my PowerPoint not doing the right thing. All right, now we are back. Okay, I just want to show you this real quick. This is my WSL Windows subsystem for Linux running on my Linux box. This is my Ubuntu bash window. You can do pretty much everything here like it's a real Linux system. So for this particular setting, I already have a GCC compiler installed on my WSL system. You can see the version here, the location here. So how does VS Code take advantage of that? Now let me go back to my VS Code. This is VS Code running on Windows. Same UI, very similar. What I have here instead is a very simple app again with a single CPP file and no configuration files, right? All it does, let me open that. It does some simple calculation, that's all. Single file. But what I want to show you that's going to be interesting is if you are working on Windows but targeting one of the Windows subsystems, like I said, WSL, MinGW, or Cygwin, now we have built-in support for auto detection of those compilers. You'll notice that, again, IntelliSense is working out of the box without me configuring anything. So I can prove that by showing you how you can see the IOStream file in here. So if I say go to definition, it's going to take me to the IOStream file. But what's interesting is if we go open in Explorer, where that file is located. You'll see here, this is actually the version that's running on my WSL system mapped back to the Windows file system. So you can see this is Canonical, Group Limited, Ubuntu, Windows, and this is where my IOStream, that version is located. So right now, VS Code knows we are targeting WSL, and RU is using the right version of the system header to help us. So here's the magic. Now you're familiar with the drill. If we go to the same edit configuration file, what we did was we auto-detected this compiler installed on Linux, on WSL, and we know this is a Linux system, so we're using the Linux-style syntax that you can specify here. We can simply rename this to be WSL if you want to name it. And at this point, if I want to say, hey, I not only target WSL, but I also target something else, like, for example, MinGW, right? We can easily create a second configuration by copying everything, and I can name it MinGW. Let me show you real quick. I do have MinGW system installed on my machine, which is located here. C MinGW, and in Bing, I have a G++, or the GCC compiler in here. So let me copy that real quick, which is this location for my compiler, and add it to my MinGW configuration. All right, let me save the file. That's all I need to do. Now coming back to my CPP file. down here, you see WSL, the name of my current configuration. If you click on that, you get a list of all the configurations you have. Now this is where you can switch between configurations. So if you're targeting multiple platforms, this is where you can switch. So let's say at this point I want to target this simple app, target MinGW instead. So by simply switching over, IntelliSense is going to re-kick off and reparse everything using everything from MinGW system instead. So we can prove that by, again, going to look at where the IOStream file is located. Now let's go to definition. Again, open this file, but this time, if we look at the file in Explorer, this is the version in MinGW, right? So our IntelliSense knows what platform you're targeting and do the right thing for you. All right, so that's all the demos. I know it's already running late, so all the demos I have for you for today. So as we speak, all these features I just showed you, all the IntelliSense configurations, auto detection we do. Let me do that real quick. Okay, a couple of things just to recap real quick. We do auto detection of the compilers to get your system includes and defines. You can modify that in the setting if you want. We do support recursive search, so you can search large folder and get all the headers in subdirectories very, very easily. We do support IntelliSense settings to be shared across different projects. So because that's another thing we have heard a lot of feedback on is I have finally got one project set up. How about if I want to replicate the same settings to a different project? I didn't have time to show you today, but that's something we also added in the latest release. VC package, as I mentioned earlier, for getting the latest version of open source libraries, and we do have integration into Visual Studio Code. We auto detect. Just to recap, Visual Studio Code makes a very powerful environment for C and C++ development. All the things I mentioned earlier, all these features you get out of the box. And if you haven't already, I strongly encourage you to try it out. Get either the stable version of VS Code or the insider version with the cutting edge daily build. On top of that, get our C++ extension that gives you the full C++ experience in Visual Studio Code. And finally, follow us on our team blog, our Twitter account. We're going to publish all the latest features there all the time. With that, please take a moment to take our survey and stop by our booth. We do have a pretty cool 25-year Visual C++ t-shirt there, so feel free to stop by, fill out a survey, and grab our t-shirt. And thank you very much for coming to the session. Thank you very much.